We'll start marking. We will get the. I think that's by next week is when I think you will be able to. Well, we are looking at the quantiles, percentiles, and the median. I think this median is simple. Median, they are saying that it's the average that is affected by extreme values. We look at what are the extreme values. Extreme values, we are looking at those values which are the outliers from the middle one. Because the one which is 50% of the numbers, that is what we call the median. And this median is not affected by these extreme values. For example, if we are saying here that if you want to find the median, the middle value, what from the observation, arrange them in order. And then the one that has this which is 50% of that through the observation, that is what is called the median. Right? So if you want to measure, if you want to find, if you have got a set of data, you have to arrange it in order of their size, and then you can find the 50% of that 50% of within the observation. And that one, which is half of that one, is called the median. So we are saying that it's not affected by the extreme values. So we talk about unaffected by the extreme values. We are looking at, for example, 43, 5, 7, 10, 300, and 720. Assuming we are looking at to find the median. So what we are saying is the median, we count the number 1, 2, 3, 4, 5, 6. Let's put another one, 1,000. 1,000. If you look at that one, you will discover that this and this one, right? This and this one, this and this one. Therefore, our median is the middle number, this one. Then we are saying our median is 10. It's not affected by this. If you look at this 10, it's unaffected by this. That 10 has nothing to do with these numbers. Has nothing to do with this number. We're just saying it is 10. Therefore, that's why I think that it should be average that is unaffected by the extreme values. Our extreme values and our values are the extreme values, which these values have nothing to do with the median, which is the median. In other words, if it was the mean, we would have used each and every element there. So our mean values can affect each and every element there, and then we divide by how many they are. It means we are involving each and every element. But if you look at this median, we are only looking at a number which is at the middle number. But the other side of whom it has nothing to do with these numbers which are there. Therefore, this is not a good way of measuring the spreading of data. Because if you say 10 is the answer, what is it telling us? If you look at these numbers, 357, 300, 720, 1,000, what is it talking about? Nothing where you can look at it from it. Therefore, it's not a very good way of measuring the spread of data. That's all. Now, let's find out the quantiles and the percentiles. And if we are looking at again, quantiles and percentiles again, they are more or less like my median, because my extreme data they are not what? They are not affected. Let's look at it.
So you mean the number
but it differs sometimes if you find that maybe my numbers are even numbers.
If there are win, you add the 2 and divide, you add them and divide by what? 2. For man, what are they saying? Answer it has nothing to do with the jack. Right? Then let's look at this is percentile and that. Now let's for percentile. First of all, again you have to order the number, arrange the orders. We are looking at now a quantile and percentile here. Let's look at this one. Let's start with a quantile and then if you want a quantile and then percentile. Now start with a quantile. Median now, we have 3 median. Let's go to quantile. Again, arrange the numbers in order to get size. So, first of all, the data has to be arranged. So, the data has to be arranged in order of their size. In other words, we are looking at whether in ascending or descending order, right? And from there, we have the lower have got 3, we have got lower quantum. So the lower quantum, I've got the lower quantum. The lower quantum is represented by Q1. Q1 is lower quantum. Q1 is lower quantum, and this is the 25% of the way through the distribution. And this is 25% through the distribution. And that is what's called lower quantum. 25%. In other words, this is 1/4, which is the 1/4. That's what it's called. 1/4, 25%, which is referred as 1/4. It's the Q1. Quartile means quarter. So lower quantile is just 25% of the distribution. 1/4, 1/4 of 100. That is 25%. And then from there we have 1/4 the middle quantile or the upper quantile. The middle quantile is the median, right? We have got the middle quantile, right? The middle quantile, if you find the middle quantile, which is I think before I have the middle quantile, which is the middle quantile, which is Q2, right? So we talk about middle quantile, which is sometimes Q2. Middle quantile, which is sometimes Q2. This is 50% of the distribution, and this is what is called sometimes known as the median, right? This is the median of the distribution. But the most important one is the lower quantile and the upper quantile. The upper quantile. Q3. So the upper quantile, this is 75% through the distribution. In other words, this one it is 3/4, right? This is 3/4. While this one is the 1/4, right? And this one is what? Half. What's that? Right? Right?
median.
Then it is for median. And where I want to the median is, we have written it. Half is the median.
So what is the quantile?
Quarter is quarter. So the most important thing is Q1 and this one. The lower quartile and the upper quartile. The lower quartile is Q1, the upper quartile is Q3. Always is Q3 and Q1. And then from there, the nth percentile now. Let's go to the percentile, the nth percentile. The nth percentile. What about the nth percentile, which is something is PA. The nth percentile. It is the value which is the 8%. So this is the value 8% of the weight to the distribution of the I will explain the way to the distribution through the distribution. Right? If you look at the 8%, like 8 is like if you say the 8%, the 10% is VP10, 20% is VP20, right? 50% is P50 here, right? This is the value of 50% of the weight. So N is any number, right? N is any number. Whether it is, what is the 10%, what is the 5%, the 5% it means P5. 10% means P10. And if it is P10, it is the value of 10% of the weight of the distribution. That's what it means. Where N is the value of that percentile. For example, 10% means P10, right? And this is the value of 10% of the weight of the distribution. If it is 10%, what it means? You have something like this, right? This is 100%. 0, 10, assuming that this is 50%. So the 10%, this one, 10%, this is your P10. It means this is the 10% here, the P10. Right? Of the way through the distribution. But the distribution has to be 100%. I'll give you an example on that one. The one who calculated the 8%. We'll see what a percent or something like that one. Let me define what is interquartile range. Let's put interquartile range. Interquartile range. Interquartile range, the range is the difference between the bigger number and the small number, right? So interquartile range, we are looking at the difference between Q3 and Q1. Interquartile range. A range is the difference between bigger number and small number, right? So interquartile range, this is the difference between Q3 and Q1 and Q1, i.e. Q3 minus Q1. This is what we are getting in the interquartile range. Where Q1 is the upper quartile minus Q1. Right? The difference between Q3 and Q1. Let's look at what are interquartile range. You know interquartile range? Let's look at another one which is another way. Right? Interquartile range. Mapeza value ya Q3. Right? Mapeza value ya Q1. 1 quarter of the distribution. In other words, you put the final number, right? You can have a number here. You can have the numbers like if you look at Yeah, you can have numbers here. You can have 5, 10, 50, 30, 72, 90. You can find in the matter range here. You can find Q3 and Q1. Q1 is 25% of the number. So all these numbers are representing 100%. Right? All these numbers are representing 100%. Find 25% of this number and then you're going to mark that one. Then Q3 is 75% of all these numbers because the number of 7 is going to give you 100%. Then you find what is 25% of this number. It might be 2. Then when you take Q3 minus Q1, what you are getting there is what is called an interquartile what? You are getting what is called interquartile range. The difference between the Q3 and Q1. Bigger number.
To find Q1 and Q3.
If I cannot find, I'm just giving you an example. I'll give you examples. I'll give you examples and how we. We'll start it from my interquartile up to the end, and then we see how we come about it. Alright, don't worry. Then another issue that I have to do is interpercentile range. Interpercentile range. Interquartile and you have got interpercentile range. Interpercentile range. What is this interpercentile range? If you look at interpercentile range again, that is now the difference between the difference between the bigger percentile and the smaller percentile in the distribution. The difference between the bigger percentile and the smaller percentile in that distribution, that is what is called interpercentile range. So range is between various percentiles can be found. You can find range between different percentiles. So the difference between the bigger percentile minus the smaller percentile, it gives you the percentile range. Right. Yeah?
About the percentile.
What has to come to your head is, I know percentile is the 100.
Yeah.
The percentage.
So that means the figures will be given will be percentages.
It's big percentages. Bigger one is big percentage and the small big again by percentages. Then you subtract the two. Depending on what are you going to want. Right? If the bigger percentage is 90, the small percentage is the 20. You can find it 90 minus 20 and your interpercentile range will be 7. But you're working now in percentages. Unlike it, our one is interquartile range. Range is just to use numbers. Bigger number minus smaller number. But now, so if you look at it, is this what we are looking here? Are they useful way of measuring the spreading of data? Assuming we are in a class here, and this is assuming you are a teacher in one of the primary schools, and you want to find the ages of the students. Then you start from the first key and it tells you that the age is this, up to the last one. Then you average these numbers in order of the size or according to my age. There are 100 kids in your class. So the first one and the is Roche. The last one who is that and then you want to find the interquartile range. Which ages are you going to use? You are going to take the smaller age here. Then by the age equals, right? You are going to use this 2. Now if you are using this 2, what about the rest of the ages? What are you doing with that one? That's how we are looking at that English body and affected what? And affected extreme values. The way the extreme values are saying, what about the other values? Are these values important? Why are we just only concentrating on smaller age, the smallest age, and the highest age? What about the others? What are you doing with the others? That's why we are saying this is not a very good tool for for measuring the spread of data. What are you using there? Smaller edge and the bigger one? What about here? It's not a very average, right? So that's what I say that again, it's a part of range. It is giving us something. Assuming, right? It's a class. You have written a quantitative techniques exam. The lowest guy has scored 2%, and the highest guy has scored 100%. Then I cannot come up with, I can't conclude it with the highest minus the lowest, and I say 98 means another young them because the range is 98. Then it is making what? Senseless. To put it another, it's making senseless because there is no sense on that one. Why am I giving you and what 2% and 100% and only using the two? Now what about the rest now? Right? That's why it's not a very good tool for measuring the spread of charge. Now let's go to interpercentile range. Let's define interpercentile range. I think you are right. With you guys, you are advantaged because when you learn these things here, you can do degree in economics and whatever. You can challenge that degree in economics, which we have got about 3 students here. You can challenge that one, which you can do it. Or you can do masters in economics and whatever, right? Yeah, which I am opting to do PhD in this one. It's here again they are establishing PhD in philosophy, PhD of course, philosophy in economics. And it's a very nice one, it's a challenging one, which you can do if you like mathematics, you can do that one. Right, let's go to percentiles. If you look at interpercentiles, let's write down. Interpercentile, we have already read that one, interpercentile.
Sir, you are saying that this kind of calculation is not good for identifying distribution of data. So my question is, so what can we use this tool for? Like, what's the purpose of it?
Why do we use this tool for? Since it's not a very good way of measuring.
Not really why, but what can we do with it?
What can we do with it if it's not useful for measuring? We're just proving to show that sometimes you can be tempted to use this, but it's not a good tool to use it. We are just like there's no way we can do it to improve it. We can't do further so that we improve this one. But we are just showing you that this is not a very good way of if management is using this, then they are doing it wrong. It's wrong. If they are taking a high smart minus low smart, it is wrong. If they are using percentages, 90% to 100% minus 10%, it is wrong. Because it is the extreme values are not what? They are not affected. What about if we have these extreme values? Extreme values we are looking at it. We are not taking them to be an outlier, but we are within the stage because we call them extreme values, and another we call them the extreme values. If you are within the stage, it means you are extreme values. But there can be others who are outside there. If we are here, we call them outliers. Those are outliers, right? They are not within your this quantity. We are calling them the outliers. Then we are going to see because there can be other data which is outlier. You cannot be using it. Outlier is most we can say the outside the what? The sex. Others are now these are sleeping in dormitories, right? What you are learning here, those are the outliers. But the extreme values you are looking at you guys who are inside, but we are not using you. It means you are the extreme values.
Okay.
So you will see from the example that I will give you. Let me just define and then you see from that one. So I like the range between various percentiles. The range between different percentiles. Different percentiles. Right? That one is. Right? I.e. 90th percentile, i.e. 90th percentile, if you have percentile.
That time for between.
Yeah, the range between different percentile. i.e. 90th percentile, let's use 90th percentile, which is the and the 10th percentile. Let's use the 90th percentile as the largest and the 10th percentile. 10th percentile. If you look at the 90th percentile, 10th percentile, and you want to find the percentile range, what you are going to do is you are going to say 90, right? 90 minus what? 90 minus which is 90 percentile and 10th percentile gives you 80%, 80th percentile, right? So this gives you 80 what? Percentile. In other words, what you are looking at is the percentile P 90 minus P 90 right? P 90 minus P 10 minus P 10 gives you what? P what? P 8. That's what it means there. That's what it means the name of that. Right? Yeah. So notice that when you are using this one, when you are using percentile, whatever you are using, whether percentile or median, whatever, when you are using this, make sure that the data that you are using can either be grouped or ungrouped data. Note that one, you have to note that the data to be used for the data that you want to use for median, percentiles, median and percentiles. So say percentiles can either be grouped or ungrouped data. Grouped or ungrouped data. By now you know what is ungrouped data. What is the grouped data? I'm not noting that. I'm taking out all this. Let's go.
So what is the group data?
Huh?
What is the group data?
What is the grouped data?
And what is the group data?
What is the difference between grouped data and grouped data? I thought we have been talking about things this hour. Huh? Right. And you look at single data and you look at less data which is in the interval. So we are talking group 2 and you have that group 2 and group. You look at the let's proceed with the and group data. Let's start with that. And group data, if you're looking at like 1, 2, 3, 5, 4, 5, that's the group data. Group data is given a range interval. 1 to 5, 6 to 10. That one is a group one because and group 1, 2, 3, 4, 5, 6, 7, right? Let's go to the other examples now. From what I have said, I will go to examples of median, examples of quantile, examples of percentile. All examples as mentioned. You can follow an example and all. If you know over the thereafter, we can point it in. Let's start it from there. Right? Now looking at the matter, we can point it in comparatively, but I think there is less to do. Let's start with the Let's start with the ungrouped data. Median ungrouped data. Let's start with the ungrouped data. And you want to start with median. You want it ungrouped data. And where you get the difference in the data, right? So for ungrouped data, where you are what called an end observation. So for any ungrouped data with I will just with n observations, right? With n observations in order of size. In order of size, the median is found by is the half n plus 1 plus 1, right? Like that. Observation. Yeah, the observation. I.e., that's an example. Example number 1. Example number 1. Find the median for this one. 7, 7. Find the median of this set. Alright, 7, 7, 2, 3, 7, 7, 2, 3, 4, 2, 7, 9. 4, 2, 7, 9, and then we have 14, 31. Let's find the median for that. Right? Find the median for that. If you look at the median for that one, find the median for this one. Not so the median will be, if you look at this one, the median, the half n plus 1. You are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. The median is equal to half n.
The one you are going to 3 and 1. The one you are going to
31.
Right? The median is going to be like that one. So it's going to be half. Hey, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 1. This gives you half 10. 10, which is equal to 5. Right? So that's the technical observation. So the technical observation from there is you have to arrange them in order of size. Arrange them in order of size. So arrange them in order of size. So it's going to be 2. So it's going to be 2, 2, 3, 4, 7, 9, 31. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 31. It's going to be that. Then so we have the series number, right? So this is the series number here. So it's the series number here. Formula this is the formula. You have to know this formula, right? Half n plus 1. Any number of numbers there plus 1, right? These are right? You have to know this one. Half n plus 1 for the median. Please know what you take. Just know that which is the number 5. So count 1, 2, 3, 4, 5. Therefore, the median is this one. So the median is this one. So this one median. 1, 2, 3, 4. 1, 2, 3, 4. Median is this one. Therefore, this one here is our median. That one is our median. In other words, that is our fifth observation. This one is referred to as our fifth observation. And it is our median. Right? Let's consider the second. Let's go to another example. Consider this set as example number 2. Example 2. Consider this set. You know, I think what you have to do is, if you were myself, you were supposed to have a lot of makeups because you have to know there are a lot of things that you have to know about statistics. You guys, this is very, very important than each and every, than any other. This is very, very important. Right? Researches, what. You can get into it easily. Because this is, even when you say you did statistics at your degree level, this is statistics. Another name for statistics is quantitative what? Techniques. Right? What you are learning here is statistics. So if you are very clever enough, you would have come up with something because you would have been gone far even what other people have never learned. So you should be able that when you are doing statistics, you can find it very easily. Let's consider the second set of data. The second set of data is this one. Assuming you have got data like 27, 29, 32, 36, 41, 36, 41, 27, 32, 27, 32, and we have got another one, 29, 39, 29, 39, and another one, 43. Right. Let's go. Consider that set of find the median. How do you find the median? So if you look at that one now, the median is equal to half bracket n plus 1. Like this one. Half. So your median is going to be how many numbers are there? Half. 1, 2, 3, 4, 5, 6, 7. Half 7 plus what? 1. With this is equal to half 8. Like this one. So half of 8 is what? 4. The fourth number is. The fourth number is your median. The next thing, arrange them in order now. Arrange them. So you have to arrange them. Arrange them in order of size. If you are arranging them in order of size, what you are doing is, let's arrange. Small number is what? 27, 27, 29, 32, 36, 39, 39, 41, 43. Right? If you go to that one, look at the fourth number. Go to the fourth number. 1, 2, 3, 4. The fourth number. 1, 2, 3, 4. You use this observation, this one. Right? And this one is the what? Fourth number. 1, 2, 3, 4. So your median is that one is your median. No, I don't want the number. Let's now give another number. What is no? I don't want that one. Actually, how many? 1, 2, 3, 4, 5, 6, 7, 8. Pakai number that. 1, 2, 3, 4. Oh, 8. Pakai 8. I want to have. Let's make them to be 8. Actually, let's give another one. Yeah, you want that.
5. 40.
Yes, you must say 40, alright? But if you give it 40, then we will use. So 40, then
Give 40.
8. 8 plus 1, here is going to what? 9. And this one is going to be 4 and a half? 4.5. 9 and a half, right? 4.5, right? Right, and from there apply 40.
41.
Huh?
40 already, no?
40.
Then 41.
41.
Then 43.
43. Okay, right? 43. Therefore, if you look at this one, so we are running away from that one. So if you look at this one, this is 4.5. So it now is 4 and a half, right? So you look at the 4 and a half. So you are going to 1, 2, 3, 4. Alright? Half and another. With the rest? 1, 2, 3, 4. Half is in between here, right? Therefore, we are using the two numbers here. Right? So therefore, from there, if such is the case, I will write here. If such is the case, what I'm writing here. So 1, 2, 3, 4.5. So it means that we are using. So we use 36 and 30 what?
36 and 39.
So add the 2. So this is 36 plus 39 is what?
75.
75 divided by 2. And this gives you
37.5.
37 what?
5.
0.5. And this is the median here. So it's going to be this one. Right? Now let's just write something here. Let's write something here. What I want to write is let's go from this. Let's write simple summary whatever. Because they want to go to what else? Let's go to summary. Let me just go to summary and then that minus what else? Let's go to summary. Now the summary, notice that